Welcome, human, to ETC Tutorials. So in this episode, we're going to be going a little bit more advanced into raycast. Actually, this is going to be more of an intermediate tutorial, so it's going to be a little bit more complicated than the previous raycasting tutorial. And if you've never done raycast before, that might be a useful tutorial. So link in the description below to how to do plain old raycasts. But in this particular episode, we're going to be learning how to do a RaycastAll. So basically what that means is it's still just a raycast, but instead of just returning you only the first game object that it finds, it's like, imagine if a regular raycast is a laser pointer, and the laser pointer just tells you where the little red dot lands on a game object, that's a regular raycast. But a RaycastAll would basically be like a super high-powered laser pointer that just burns through everything, and it will tell you everything that it hits. So it's going to return us an array of raycast hits variables. So that way we can raycast through objects, and we can sort through all of that information and find out all of the information that we want to find. So I'm going to quickly demonstrate the script and how it's going to behave when we are done with this tutorial. So very similar to the previous raycasting tutorial, except this time I didn't bother putting in a if input.get mouse button down or mouse button or anything like that. Just so that now it's going constantly. So basically that's the first difference. The second difference is the fact that it will now go through game objects. So as you can see, when I jump up, you can see it will actually stick to the floor, and it is only going to stick to the game objects that actually have the tag that we are looking for. Another thing is actually we have two invisible triggers up here. And also the floor doesn't have a tag of level parts, so it's actually going through. So actually let me show you in our scene. If I go to the Raycaster, and here's the script right here. This is the cube that we are changing the position and rotation of to make it stick to any surface that has the tag of level parts, as we can change down here to anything that we want. So in this case, we are only looking for level parts. And actually, let me quickly, let me disable this one and enable that one. And then I will show you with a regular old raycast a particular problem that we are going to fix. So as you can see, I can make my cube thingy stick to stairs. And then all of a sudden it's floating in the air and it's getting blocked by a trigger. So that's basically the problem right there, is that the raycast is getting blocked by a trigger. So we're going to use a RaycastAll. So let me disable that script and enable the RaycastAll cube J script. And let me show you when I go to the top of the staircase. Whoops, I missed that jump there. Our raycast is raycasting against everything in the scene and is returning us whatever that it finds that it has the tag of level parts. And as you can see, I am going through the invisible triggers and it's not getting blocked like it was before. So that is a huge advantage to using a RaycastAll, is particular scenarios like that one. So let's actually learn how this works in code. One thing, I actually probably should have mentioned this a little bit earlier, is that you will need to know how to use an array. I will explain it slightly in this particular episode, but in case you don't know what an array is, hopefully in the future I will be doing some tutorials over JavaScript arrays and C# arrays. I think they're actually both pretty closely similar. But I will put a link in the description below in the future once I actually do those array tutorials. But until then, just saying we're going to be using arrays. So yeah, let's get into that. All right, so let's take a look first at the JavaScript, and then later on I will jump into the C# script and show you the very few changes. There's hardly any changes in the C# script, so I'm just going to explain it mostly in the JavaScript. So the two variables that we have in the inspector are var cube transform. So cube is going to be of type transform, and that is basically saving this game object right here, the thingy with the little sphere on it, to show us where our raycast actually hits. and whoops, let me go back to our raycaster, and all you got to do is drag and drop it onto there like that to actually remember the transform so that we can change the position and rotation of that cube later on. So that is that. And then we have a variable check or tag check, and this is going to be a string. And this is just like in our case, we had it set to level parts, but we can set it to anything that we want to determine what game objects it actually detects for and what tag it is actually looking for. And unlike the previous tutorial on basic raycasting, there is no option in this particular situation. I'm sure we could create an option, but that kind of defeats the purpose of a RaycastAll raycast. So we're just raycasting for one particular tag. So let's actually figure out how we're going to do that inside of function update. So this is all function update right here. So this loops every single frame. So everything that I've highlighted right now happens every single frame. So the first thing is we're going to create an array variable of type raycastHit and call it hits. So var hits raycastHit, and then we have an opening and closing square bracket to show that this is going to be an array or a list of raycastHit variables. The next variable is hit use, and this is of type raycastHit, and there are no opening and closing square brackets, so this is not an array. So this is just a single raycastHit variable, and basically this is going to be, we're going to save what raycastHit, because every time, or for every single game object that our raycast detects, it's going to return us a raycastHit variable, and then we're going to use a for loop to sort through all of those raycastHit variables, and then we're going to find the closest game object that has the same tag as the tag that we're looking for, and then we're going to save that raycastHit inside of hit use to determine where we actually want our cube thingy to move around and what game object we want it to stick to. And then the next variable we have is found hit, and this is a boolean, and we're setting it to false at the beginning of every frame. So this starts off as false, and later on we will set it to true if we actually find a raycast and if we actually find the tag that we are actually looking for. Okay, next we're going to actually do the actual raycast, and the raycast in this particular situation, we're actually doing a very simple one, but you can do all of the raycast tricks with distance and layers. We'll get into layers later in a later episode. But I guess distance, you can also put array in there as opposed to an origin and a direction, which array basically is an origin, and a direction is just inside of a variable that's called array. Array as in R-A-Y, not array as in A-R-R-A-Y, just R-A-Y, ray. Just I thought I'd point that out because I know that they sound exactly the same. I just realized that. But anyways, RaycastAll returns you an array of raycast hits. So that is why we have hits equals on the left-hand side of the function raycast or physics.raycastAll, because hits is the array of raycastHit variables. So we're going to be saving all of the information from the raycastAll inside of hits. So physics is capitalized because we're just, in general, we're just talking about physics, I guess. We're just talking about the class physics. I don't know if that's technically what's exactly going on, but basically we're just talking about physics. We're not talking, or we're not looking at any particular game object or any particular component specifically. So that's why we're capitalizing it. So just a little, I'm sure you probably have figured this out by now, but you don't need a rigid body or anything like that, or any particular type of component to actually do a raycast. You just call it from the physics class, and you can call a raycast from anywhere, basically. All right, and then we have RaycastAll. This is the function RaycastAll, and in this particular situation, we are just giving it an origin and a direction. So the origin is transform.position. So let me show you, let me zoom in here so you can actually see. So this is the origin here. We have a cube that is a child of the main camera right here on our first person controller. So here, whoops, wait, here's the cube that's supposed to represent like a gun or something, and here is the raycaster. So this is what the script is attached to. So our raycast is going to start exactly right there, so right where my mouse is. And then it's going to shoot in this direction using transform.forward, or in other words, +1 on the z-axis. So this is just a directional vector 3 with a magnitude of 1 that represents the forward direction of the game object that this script is attached to. So in other words, just this blue arrow right here. That's what that vector 3 represents. So we have our origin and direction, and because we didn't give it a distance, it's going to just shoot on infinitely. It's just going to keep going on forever. It's just going to, by default, have a distance of infinity. Okay, so we shot our raycast, and we saved all of the hits that it found inside of this array here, hits. So now we are going to sort through it. But before we sort through it using this for loop right here, we need to save a particular variable to actually sort through all of that, because we want to know what the nearest hit is, because we want it to land on the first game object with the tag of level parts, because a RaycastAll doesn't return us the hits in a particular order. It just kind of, as the engine finds them, in the order that it finds them, so it's not necessarily going to be measured by distance or anything. So basically it's going to throw you all of these raycast hits into, or it's going to throw them at you at a random order. So we're going to sort through them and find out which one is the closest to the player. So we are going to create a float variable that before we go through the for loop at the beginning of every frame, we're going to set to infinity. Excuse me. So basically what we're going to do is every time we find a hit, we're going to take that hit and then we're going to say like, okay, does it have the tag that we're looking for, in this case level parts? And if it does, then we're going to measure the distance between that point that we hit and the origin point, or basically transform.position of where we actually shot the ray from, so the game object that we actually shot the ray from. And basically we're going to say if that is shorter than shortest dist, then we're going to save that raycast hit, and we are going to set shortest dist to that particular distance. So we need to start with infinity because everything is smaller than infinity. So we're just starting off with infinity at the very beginning, and then we're saying if it's shorter than infinity, which anything that we find is going to be shorter than infinity, then we're going to save it, and then we're going to set the shortest dist to that distance. So let's actually take a look at what that looks like in code. So first of all, we're declaring the variable shortest dist. It's of type float, and then we're setting equals mathf.infinity. So this will set this float to infinity at the beginning of every frame before we go through this for loop. So this for loop, we're doing kind of a traditional for loop in the sense that we're using the variable I, and we're just going to count up, and just every time that I is still smaller than hits.length, then we're going to run through the loop one more time. So the first section of the for loop is var I of type int equals 0. So we're starting at 0. So we're starting at the very beginning of the array because all arrays start on 0. And then here's our condition, which is I is less than hits.length. So remember, hits we declared up here, and we set it using the raycast right here. So hits is the array that is saving all of the raycast hit variables that we found from our RaycastAll function. And then .length, we're just getting the length of that array. But remember, when you do any type of array, .length, it's basically the last element on the list is going to be a -1 from how many length returns you. So if you have an array that's only 1 long, then the array dot length, so in this case, let's say we only found 1 raycast hit. So hits dot length would just return you 1. But the first element, or the first hit, will be 0 because arrays start on 0. So you have to take that into consideration. So that's why we're using smaller than as opposed to smaller than or equals to. Whereas if we did smaller than or equals to, then it would get to equals to, and it would like look for the last element on the list that is one more than how many elements are actually on that list, because list is always plus one of the latest element that is on that array, if that made sense. So basically, if this condition is still true, then we're going to run through all of these lines of code. And then after we run through all of these lines of code, we're going to do I++, which is short for I plus equals 1. So we're just adding 1 to I every time we run through this. So basically, we're going to count up until we go through every element on the array hits. Okay, so hopefully that made sense. So the first thing we're going to do is an if statement right here that says if hits I.transform.tag equals tag check. So we're checking for the tag to see if this hit that we're looking at right now. So right now, like let's say we start on 0, we're looking at the first element on the list inside of hits. So the first raycast hit variable inside of hits is so we're checking that. So we put I inside of square brackets on hit so that we know which element we're looking at. So we start with 0 and we count up from there. And then .transform.tag, we're just getting the tag from the transform, because we get a transform variable just to represent the transform that the raycast, or the transform of the game object that the raycast actually hit. And then we're pulling the tag out from that. And then we are just comparing it to using equals equals to tag check, which is the variable that we're going to set in the inspector up here. And in this particular game, I'm using level parts as my tag that I am actually checking for. So basically this line of code says, does the game object that we found with the RaycastAll function have a tag that we're looking for? Yes. Okay, then we will check the next if statement. And actually, we could have let me comment this out just to kind of show you an alternate way of doing this. I can take this, copy, and then I can put it all inside of here with an and symbol in there so that we have two different things in there. So that's an alternate way of writing it. It should work exactly the same that way. But the next condition that we are going to check is how far away this is. And actually, I also just realized that we could have just written hit dot distance and get rid of this vector 3. Why don't I go ahead and explain it, and then I'll show you the alternative. So we're using vector3 dot distance, which is a function in the vector3 class that is basically, it's kind of like taking a tape measure between 2 points in 3D space, and it will tell you how far apart those points are. So the point that we're giving it is transform.position, so where we shot the raycast from, so the game object that this script is attached to hits I.point. So hits I, the hit that we're looking at right now as we loop through the for loop, dot point, so the point in 3D space that the raycast actually hit, and then we measure that distance. And then if it is smaller than the variable shortest dist, then we will run these 3 lines of code right here. But the alternative way of writing it, and this would be much faster, is hits I.distance, and just delete this whole vector3 nonsense stuff. I believe that should work exactly the same, because if I actually pull up Chrome here so we can see the Unity scripting reference, raycast hit has this right here, distance, which is of type float, and this is the distance from the ray's origin to the impact point. So that's basically what we're using vector3.distance for in that particular situation. So that is how to use that. So if it is shorter than shortest dist, then we will run these 3 lines of code right here, which are hit use equals hits I. So we're going to set hit use to hits I. So the hit that we're currently looking at hits I. So remember, I is going to count up 1 every time we go through it. So we're going to look at a different item on the array of the array hits every time we go through this for loop. And every time we go through this for loop, we check hits I in this if statement right here. So if hits I has the correct tag and a shorter distance than the hit that we found previous to this one, Then we're going to set hit use to hits I so that we can later on down here change the position and rotation of the cube based on which raycast hit variable we actually want to use based on the tag and distance. The next thing we're going to do is shortest dist equals vector3.distance transform.position or hits I dot point. So once again, we can actually make this shorter by doing just hits dot distance like that and just deleting all of that. So that's actually much shorter. So now the shortest dist that we have found so far is the distance that we just found in this if statement. And then we're going to set found hit to true so that we actually know to rotate and move the cube because we actually found a raycast hit with the correct tag and the shortest distance that we found, because every time we find a distance that's shorter, we just overwrite the previous hit that we found. So let's quickly just go over this down here. So if found hit, so we set found hit to true right here, and we set it to false at the beginning of every frame every time we loop back through the update loop. So if it is true, that means that we found a raycast hit with the correct tag and everything. So we're going to do cube.position equals hit use dot point. So that's the position in 3D space that this raycast actually found a raycast hit. And then we're going to just make the cube snap to that position in 3D space. And then we want to change the rotation of the cube because we actually want that cube to snap to the surface of whatever we are raycasting against. This is useful for things like bullet holes or blood spatter and things like that. And because cube.rotation is actually of type quaternion, so a rotation in 3D space, we need to change hit use.normal. So hit use.normal is a directional vector 3 with a magnitude of 1 to represent the direction of the face that we collided with. So the same analogy as I used in the previous episode, just going over basic raycasts, is if I was raycasting against this piece of paper, so my finger right now is the ray, and I hit it, the normal is going to be a vector 3 that represents this direction, so pointing away from the face that the raycast actually hits. So that is a vector 3. So when we put it inside of the function look rotation, we're basically converting that vector 3 into a quaternion. So now all of this is a quaternion, so we can save that into the cube's rotation to update the rotation of the cube so that it actually sticks to the surface of everything. And since I made a couple of changes in the script, why don't we go ahead and test it out? And it looks like it is working just fine. So that is basically how all of that works. So let's go ahead and jump real quick into the C# version just to show you the differences in syntax. There's really not that many differences. Actually, there's only like one difference I can think of, and that is that we split up declaring the variable shortest dist and setting the variable shortest dist to mathf.infinity. So if I go into the JavaScript version, as you can see right here, we have it all in one line of code. We're declaring the variable with var of type float right there, and then we're setting it to mathf.infinity at the beginning of every frame so that it resets itself back to infinity so that we can check the distances every frame. Whereas in the C# script, we need to declare it, and then in a separate line, we need to set it to mathf.infinity. Otherwise, it will only set to infinity once, and then it won't reset every frame, and we need it to reset every frame so that we can remeasure out all of the raycasts at the beginning of every frame. And I believe that is everything. Inside of the for loop, we write int I instead of var I of type int. Just typically how you declare variables inside of C#. Oh, I guess this is different here too. So raycast hits, square brackets, hits right there. So that we're declaring the array of hits that we're going to be saving. Oh yeah, also the two variables from the inspector are up here. And Down here, raycast hit use equals new raycast hit, opening and closing parenthesis, because in C# we can't leave any open variables. We can't say, hey, this is going to be a raycast hit, but it's not going to be anything for right now. Like C#, it needs to be something, so we're going to set it to a blank raycast hit variable. So when we write new raycast hit with opening and closing parentheses, basically that means create a new raycast hit, so a completely blank one with no real information in it, and we're going to save it inside of hit use, and then later on we're going to overwrite that information down here with hit use equals hits I, and I believe that those are the only differences between the C# and JavaScript version. So I'm just going to scroll up and down in case you want to like pause the video and actually check it exactly. I guess I might as well do that for the JavaScript as well. I'll just scroll up and down so that you can check it exactly. I'll also upload it to MediaFire, and I'll probably put like all 4 of these tutorials in a single zip folder and save it. A link in the description below on MediaFire so you can download that. So yeah, that is how to use the function RaycastAll. So I hope you enjoyed this video and you got the information that you needed out of it. So yeah, I guess until my next episode, I will see you later and keep making games.